Right now I'm just kind of glancing at last night's homework. Last night's homework was long division, which is fairly lengthy. You could have done number 1 easily, a different way. Could have done number 2 a different way. Number 2 had to be long division. Number 3 had to be done with long division. Number 4 did not have to actually be done with long division. What's the difference between 2, 3, and 1 and 4 on last night's homework? Power of x. 1 and 4 are actually first power. That's the highest exponent. Okay? When the highest exponent on your divisor is x in first power, you actually get to use a different technique to do division. If it's something like x squared, x cubed, x to the fourth, that requires long division. You didn't know about this technique yesterday. Well, today you learned that technique. The technique is called synthetic division. And if you are dividing by something simple, such as x plus 2 or x minus 3 halves, where x is the first power, you get to use this technique. I'm just reading off the notes right there. It is different, okay? So we're going to divide 2x cubed plus x squared minus x plus 5 by x plus 3. Now I'm going to start with this. If I think about that being equal to 0, what does it mean x absolute is? All right, that's the first thing you got to do. You actually have to determine the value of x. That would make it 0, okay? The divisor guy is upside down. Just how it's done, okay? Throw negative 3 there. No x plus 3, just throw the value of x. It's actually a kind of, I like to call it a two-story house. You got some stuff up in the top floor, the second floor, and there's some stuff down on the first floor. The top floor is full of the coefficients. I'm using a big word there, coefficients. What do we mean by coefficients? The number that goes to the variable and the constant itself at the end. Okay? Just coefficients. And I'll walk you through it, and I've got an acronym for you to remember how to do this. But the very first thing we do is we drop the first number. We drop that 2. First thing you see, you drop it. It falls all the way through the first floor down to the basement, okay? And then we multiply negative 3 and 2. We're going to multiply negative 3 and 2. That goes on the first floor. And then you add. You add 1 and negative 6. You just add down. What's 1 plus negative 6? Negative 5. What do you think you're going to do next? You're going to multiply. Those two digits get multiplied together. Just like I did here to get that. I'm going to find the product to be negative 3 and negative 5 and throw it right here. What is product of negative 3 and negative 5? 15. Try to get us. You feel like you should do now based on past prior experiences. Add. That'll give you a 14. Maybe multiply. Negative 3 and 14 makes a negative 42. And then add. 37. Now, before I talk about what that is, this is the acronym to remember how to do synthetic division. DMA. What's the D stand for? Drop or down. What do you want to think? Why do I have a bar over MA? You repeat it until you run out of numbers, right? Multiply and add, multiply and add, multiply and add. It's a shame it's not DAM. I'd love to have a good excuse to say DAM. I was saying DAM, okay? Huh? DMA is good. DMA is a stimulant that used to be used quite often by athletes and bodybuilders, but it's been banned because it makes hearts go poof. It was legal to speed for about 3 or 4 years. It made cars? Athletes. It made hearts go. Hearts. I mean, teenagers were taking this stuff, and it was in pre-workout. And instead of 1 or 2 scoops, they only take 6. So they OD'd on it. There's too much of a stimulant. It wasn't that the stimulant itself was bad, it's that stupid people were taking too much of it. It was good stuff. They weren't taking it in moderation. Because yes, I bought pre-workouts with it, and it was good stuff, and the new stuff sucks. Stupid people taking too much of it. Now, what does this actually mean? Well, when you do long division, the last thing you run into is remainder, isn't it? Now you're going to have to think about this in your head. We had plus the remainder over divisor. Before that was usually a number, a constant. It was part of the quotient. This stuff right here is part of the quotient. Okay? This guy is a constant. What precedes a constant is almost always an x. What precedes an x is usually an x squared. So the result is 2x squared minus 5x plus 14 plus the remainder of negative 37. You always write this as quotient plus remainder over what? Divisor. What was the actual divisor in terms of x? X plus 3. You guys did long. If you did your homework yesterday, you did long division. This was far quicker and far easier. It was one line and done, and you had it. So the big things is there are a lot of kids who, most kids actually do figure out long division. A handful of them always struggle with what's going on down here. I don't know how to explain any other way. The last piece is remainder. The remainder is preceded by a constant, which is preceded by an x, which is preceded by an x squared. And if there was something before that too, what would it be? It'd be x cubed. Just kind of work from right to left.
So the last number is a 0, that means
The last number was a 0, it was a factor, yes. This is not a factor, no.
and it's like this with even more than 4 numbers.
Yeah. The deal is what you're dividing by has to be simple.
How do you add in the placeholder?
Well, you add in placeholders if you need them. There's an example for that. No worries. All right, this is a remainder theorem. Your homework, the first 4 questions deal with remainder theorem. It's not clear. I wish I had not copied this out of a textbook, the definition, but I did. And I also made a misspelling error. But a polynomial, f of x, has a factor x minus c if and only if f of c is 0. What does f of c being equal to 0 mean? It means if you plug in this value, whatever it is, y is 0, okay? So it turns out that if you get a 0 by plugging a number in, it is also a factor. So determine if x minus 4 is a factor of this guy. What you think about is, and we're not even going to do the easy example. We'll do the one beneath it. If x minus 4 is a factor, think about doing cover-up methods and stuff like that, right? Then x minus 4 has to equal what? Which means x is 4. Our remainder theorem says you can determine real quick if something is a factor just by plugging it in. So I'm going to find f of 4. There's your function notation, which means every time I see an x, replace it with what? 4. You do your homework on this piece, and it's the first 4 questions. Just show me the plugging in 4. I don't care if it's a storage feature or not. Just show me that you actually understand what it means to use a little bit of function notation. It's the only way you're going to get over it function with your grade. The only way to get over it is do it. Now I'm going to use a storage feature even though I already know the answer. Should. It's 3rd time today. First period, I was wide awake and I tried to see if they could beat me with a calculator, and they couldn't. See, I've already wasted 20 seconds of my life and I could have been done with this thing. And if you go get one of those calculators that's slow that you have to wait 30 seconds on. Whoops. Sorry, I said I was going to use a storage feature, didn't I? Take a 4, STOX. We've been through this. 3x to the third. Pay attention to your calculator. This one goes up next. I know it's 0. Unless y'all are not listening to me. I know it's 0, kids. It's 0. Who would have thought? So what does that mean? Yes. X minus 4 is a factor since f of 4 is equal to what? 0. You remember seeing anything like that on that little EOC practice y'all did? It's this section right here. They love using function notation, stuff like that. And it's on the real EOC, stuff like this. You just have to understand notation. It's not meant to be hard. That question that this showed up on was a very easy question. Very, very easy question. Most kids will miss it because it's notation. All right, so moving on to the next slide. That's all I'm going to talk about with the remainder theorem. Factor 3x cubed minus 4x squared minus 28x minus 16 completely given x plus 2 is a factor. That means multiple things. But to me, it means most importantly that x is actually equal to what? That's what it means to me. X is actually -2. Now, do you want to do this as a log division or do you want to do that symbolic division? That's the whole point of the day. Let's do symbolic division. Remember, it's a 2-story house. What's right in front of that 2-story house? -2. What do we load up top, second floor? Coefficients, which are
3, -4, -28, -16.
And you really got to be on autopilot if you're not following along here as to what's going on. You are zoned out. You are not on the DMA drug, you're on some other drug. You're on DMA, man, your attention be just crystal clear. Yeah, you can't buy it anyway. It was great stuff. And I got the best shape of my life in that pre-work zone.
That stuff now is like crazy and stuff like that.
What is 3?
Break it down. Or drop it.
This was back when Rain was here, and they actually used to buy that stuff. They would buy it for football players. Pre-workout so they could have really good practices. Yeah, it helps. Drop the 3. What do you do with the -2 and the 3? Multiply. There's another one. It was actually a couple years ago. I remember like Joey, what was his last name? Calder, man. One day in class he was just shaking. I was like, uh-oh. Yeah, too much pre-workout. All right, so -4 and -6. What are you supposed to do with those two pieces?
We'll add it.
Add them. What do you get?
-10.
-10. Adriana, do you know what we do next? We dropped, we multiplied, we added. Think about that acronym, DMA. MA is repeated, so what's the next step after addition? Multiply. -2 and the product of -10. Which yields us a what, guys? Positive 20. And after we multiply, we add. It's going to give us a -8. And after we add, we multiply. Which gives us 16. And after we multiply, we add. That's really all it is to it. Was the 0 expected?
Yes.
Why?
Because it says x plus 2.
We were told it was a factor. It's supposed to go into it nicely and cleanly with a -0. And now you're asked to go ahead and factor it completely. So when I factored out x plus 2, which means I pulled it from the equation that was given, I was left with something. Remember, this guy is the remainder. What precedes the remainder?
It's a constant.
What precedes the constant?
X.
What precedes an x?
X squared.
So I pulled out x plus 2, what was I actually left with?
3x squared minus 10x minus 8.
Now it does say factor that thing completely. You did the initial step. You went from a cube to a quadratic, and you were supposed to know how to factor quadratics. Let's take straight to 3x squared.
3x.
That's 3x and 1x. So shrink this up so I've got a little more room with you. X plus 2 is along for the ride. But it takes a 3x and a single x to create the 3x squared. And then you got to worry about factors of negative 8. So when we flow, we get to negative 10. What's it take to make a negative 8? 4 and 2. It's probably going to be a 4 and 2. It's about placement. It'd be nice if we had all day to do things in here, but it's going to look like that with the numbers because the outside makes 12 and the inside makes 2. And the goal is to get to a negative 10. So one of them's positive, one of them's negative. I think the outside needs to be negative and the inside needs to be positive. Is it completely factored now? Yeah, it is. It is completely done. Kendall had a question earlier about placeholders. Well, Kendall, do you think you need placeholders? Of course you do. This thing jumps from x cubed to negative 8. What's missing? X squared and what else? X. It is missing those pieces. They're there. They're understood to be there. They really are understood to be there. But if it was normal standard form, we typically would see plus something x squared plus something x. That's what we'd see. That's there. It's just understood to be there. And you need those placeholders. So we're going to put them in as zeros here. Now x minus 2/3 is the factor. What does that mean x has to be?
Or 2/3.
Now, I help you guys set it up. I want you to do it. Please don't be the kid who sits there and says you don't know what to do. Are you telling me you don't know how to multiply 27 and 2/3 with a calculator? Because I've had to help kids do that today. You type in 2/3 times 27, don't you? I'm not trying to be rude, but that's beyond ridiculous. Drop, multiply, add, multiply, add, multiply, add, multiply, add. So you're done with multiplication and addition. Acting like you never took 2/3 of a number before. Beyond ridiculous.
I have these two, also with that number right there. So that would just be
Yeah,
18.
that number, there's an arrow that you said, you're putting 2 probably goes in the next slot.
But it would, I would, okay.
Yeah, you'll add down. And you'll do 2/3 of 18. Hey, you got a 0. You got a 0. You got a 0.
Oh, I thought you were on my grade. I was like,
You
no,
got
that's
0.
wrong.
You got a 0. You got a 0.
That's how I work as well.
You got a 0.
Great, or like a.
You have done 0.
Same zero.
You're supposed to get a 0, aren't you?
Yeah.
Yes.
Are they still going to smile?
What's up?
Is the back of the
Yeah. you doing all that with never adding? Oh. First off, seven is 18. Oh man. Where are you? Dropped. Okay. You have an arrow that says you dropped 27, but you wouldn't 18. You dropped 27, but you were 18. But you're doing something wrong in calculating. Plus 18, it's supposed to be 27. No. Yeah, off my head. That's about all the time I want to give on that one. Drop 27. 2/3 27 is 18. I add, I get 18. 2/3 18 is 12. I add, I get 12. 2/3 12 is 8. I add, I get 0. When you have kids, for the love of God, teach them how to multiply, add, subtract, and divide. I don't care if YouTube has to do it. Somebody needs to teach you guys how to add, subtract, multiply, and divide when you're young. You not see the consequences of this? They're huge. World math, they are. Now you pull it out, x minus 2/3. When you pulled it out, what was left? 27x squared. It's 18x plus 12. There is a little bit of factoring to be done with this thing yet. You can't actually factor the second piece in terms of the product of something times another side. Because look at that thing, 27x cubed minus 8 is the difference of 2 cubes. The first piece gives you the answer, the second piece gives you the imaginary that never factors. That's the imaginary piece right there. But it does, each of the 3 digits in it have something. What do they each have? 27, 18, and 12, what do they each have? What constant? 3. I'm going to pull the 3 out of them. I'm actually going to throw it on the first set. I pull a 3 from 27, I have a 9. I pull a 3 from 18, I have a 6. And I have a 4. Now, the reason I did this was to make it look prettier. Now, there's a reason I threw it out front, too. Now I can put it in here, where it actually belongs. 3 times x is 3x. 3 times negative 2/3, 3's cancel, minus 2. 9x squared plus 6x plus 4. Now, if you know your a cubed minus b cubed pattern, you realize that's how that thing actually factors. 27 is 3 cubed, so a is the 3x piece. 8 is 2 cubed, b is 2, so we have 3x minus 2. Then we square the 3x and we get 9x squared. Product of 3 and 2 is 6x in the middle. Square the 2 at the end plus 4. All right, what's next? We're only going to do one more. Stinking bell. We're going to do this one. You are given the expression for the volume of a rectangular prism. Find an expression for the missing dimension. And bummer. Long. And it won't hurt much. So you're given the formula for volume of a cube. Volume of a cube, by the way, is our rectangular prism is length times height. And you've got the result of multiplying the length, the width, and the height together. It's that 2x cubed piece up there. The task here is to find the missing piece. It's actually really easy to do. I've got a little note up here that says you can do synthetic division more than once. You can do it as many times as it takes. Maybe once I finish up with them, I'll get to you. What I'm going to do is I'm going to divide out the x plus 2 and the x plus 4. And those are simple things. They can be done with synthetic division. And you can do synthetic division more than once. Second floor of the house loaded with a 2, a 17, a 46, and a 40. What do you do with the 2? Drop it, kids. Are we messing up synthetic division? This is one of the easiest things you'll ever do. By the way, I did forget something. What goes in front of this thing?
2.
You can either do the -2 or the -4, right? Which one do you want to do first? It's a smaller number. Now what do I do with that -2 in front and that 2 down low? Multiply. -4 goes in the first open slot. When you add, 17 -4 makes it 13 last I checked. And then you multiply and you get a -26, and you add and you get a 20, and you multiply and you get a -40, and you add and you get a 0. All right, now quick there. Do synthetic division again. Do it like this. Pull it from what's left. You already factored it. Now it should be easier to factor it again. No, you don't start all over. You have reduced it. You have factored a piece out. Work with what's left. We still drop the 2. We still multiply. -4 times 2 is -8. We still add. We get a 5. We still multiply. We get a -20. We still add. We get a 0. We should have 2 because that was another factor. We should have got a 0. That's what's left. What is this?
2x.
This is 2x plus 5, constant. Sorry, remainder, constant, x. Missing piece was 2x plus 5. And if you took 2x plus 5 and you multiplied it by x plus 4, and you multiplied that result by x plus 2, guess what you get? Polynomial up top. Volume polynomial. And that's it. There's only one long division problem on your homework, and it's there to make you appreciate synthetic division.